I've always been mechanically inclined and loved electronics. Even very first thing I did was take a clock apart and put it back together again, you know, about 5 years old. So it's just been natural for me to do things like this. So I got into electronics, got all my training in the military, and went from there. You know, had a lot of different fields I was in. Got into LEDs in one of those companies, and I saw the future on it. This was back about 1970, and I loved the LEDs from that point on. You know, I could just see all kinds of new products being brought out on it. It took me a long time before I really, you know, did something myself, but I'm glad I started back then. Back in the early 60s, there's a little controversy on that, who actually started it, but thank goodness somebody came up with it. And it took a while for them to catch on. It was a new product.
Well, I'm a fifth-generation native Texan, and I love doing genealogy research, but I also love libraries. So at the moment, I'm serving as the Friends of the Library Association president in Cleveland, Tennessee. I enjoy hobbies and that sort of thing, and Dennis and I do a lot of hobbies together. We do trains, and we did our Christmas light display together. He basically told me where to stick stuff, and I stuck it in the ground or tied it to trees or whatever. So that's kind of what I like to do. Well, we had about 46,000 lights on our house, and the first year Dennis put it up, he said, "I've got this thing I want us to do," and I said, "Okay." And he puts the lights up, and he puts some snowflakes on our roof, and I walked across the street at dusk, and he turned all of it on, and I looked at him and I said, "You know, we need more snowflakes." And so from there, we proceeded to expand lots before we finished. And we supported a charity called North Dallas Shared Ministries. And so when people came, we had a public service announcement where we asked them to either make a donation of cash or to leave canned goods in a box. And our last year, when we had this, we raised over $1,000 in cash for this charity and over 500 pounds of canned goods. So it was a great pleasure to do that and offer assistance to folks that needed it.
Basically, they were being used for indicators and electronic equipment, you know, power light, you know, the lights on or off. And there was not a lot of variety in LEDs. Basically, there was only one, red, and very dim, you know, not very brilliant or anything like that. And other colors came along later, yeah, yellow and orange, and then there seemed to be a stopgap at that point in colors until technology caught up a little more, and the green and blue came out, and then the white. And technology helped increase the intensity of them to make them more pleasing to use them for other items, flashlights, Christmas lights, car lights, dash panel lights, you name it. It's hard, even your TV is backlit with LEDs today. LEDs are solid-state devices. They turn on when a certain voltage is applied to them, and they will start glowing. It's a diode that will light up. An incandescent is just that. It's a filament encapsulated in a vacuum, and you apply power to it. The life cycle of an incandescent is very short compared to an LED. You know, you might get a couple thousand hours out of an incandescent light. You'll get 40,000 hours out of an LED. to make an LED in different colors, you have to use different elements in designing the LED itself, and this is what makes the LED give out its color. It's not like an incandescent where I can take the bulb and paint it and come out with a different color. LEDs don't work well that way. You know, they don't show the color properly. So they have to actually make the color in the LED itself and then encapsulate it into a plastic housing, and sometimes they will color that to enhance it too, the same color that they're trying to show you. I met John through a mutual friend, and I invented this, or I had this product, and I kind of showed it around locally, and everybody loved it and wanted to buy it. I was hand making them all, but I couldn't find anybody to actually look at the whole thing. So a friend of mine, he says, well, I know John, and he says, let me contact him and see if you want to talk to him. And he's interested, and he did. A couple of days later, he actually came to Texas for other business, and we met up, and I showed him my device, sat down with the whole thing. He says, you'll be talking to me, you'll hear from me here soon. And I said, thank you and all that, and went on my way. And 2 days later, he says, get on a plane and get up here. I sat down and worked on a little bit, you know, what it was going to take to test the light strain. And I worked on that for several weeks. I had a big box of light strings that were bad from a job that I worked at. And they gave me all these defective light strings. So I'm sitting there saying, how am I going to fix these things? So I went out and did a little work on the whole thing and decided the only way to do it is you have to penetrate the wire and get in and actually make a connection in the light string in order to test it. Because LEDs just work totally different than an incandescent. You can't use an incandescent tester to test an LED light string. You will destroy it. So I worked on it and worked on it and worked on it, and then I tried to figure out how am I going to penetrate it. And I came up with a pair of pliers. And I sat there and I looked at it. I said, well, I can't use metal pliers. That's very unsafe. So I found plastic ones. And I bought them and modified them and put the wiring needed to make it, and in my garage and all that, and came up with a problem. And that is I couldn't use a pin. I needed a pin to penetrate it. So at that point, I had to bring my better half in. And with her craft hobby and all that, and she went through all her articles that she had and came up with a pin I could really use. I came home and says I wanted to do an animated light display, and that's one of the reasons I got all the lights and all that. And so she says, okay, and she says, well, what's it going to cost and all that? And I told her, well, we'll keep it small and simple this year, and it costs X amount of dollars. And she says, okay, let's go ahead and do that. When I bought the devices I needed to build the display, the control boxes and all of that, and fix the light, had the lights fixed and working on that, working on the programs, and I would show her one and she would look at it and go, is that all you can do? And I says, yeah, with with our max that we did. She says, we need more channels. So I said, okay.
We need more snowflakes.
We need more of this, we need more of that. She was the one who built the display.
It got pretty big. He came in and he said, I need a pin to put on this. And I said, what are you talking about? So he showed me his little pliers. And I said, well, what, a sewing pin? Would that work, or a needle? Well, we looked at the needles, and needles, you might not realize, but most sewing needles are quite flexible. And he said, no, it can't bend. It's got to be stiff. So then I brought out some regular sewing pins, which are usually about 1.25 inches to maybe 1.5 inches if you buy the larger size. And he says, well, no, I'm not sure that's going to work. Well, then I said, well, I have these little craft pins, and they're about maybe 3/8 of an inch probably. And I used them to put sequins and beads on styrofoam Christmas balls because I had made some of those for my kids one year, and I had this little stash of leftover sequin pins. And I gave him one of those, and he said, oh, I think this is going to work. I think this is perfect. And so he went out, and he came back in a little bit later with this big grin on his face, and he says, well, it worked, and it worked the first time. I tested, and it worked.
The problem I was having is I needed a pin that I could solder a wire to because I had to make an electrical connection to it. And most pins are stainless steel or some element you can't solder to. And so fortunately, my wife had a pin that I could use. My invention actually plugged into the wall, the one that I showed John here, and we all worked on. And the first production run was that product. But in the process and all of that, because of possible safety issues and all that, they decided to go a 9-volt battery way. So then a new design was brought up to use a 9-volt battery and not plug it into a 110. With the proper circuitry in there, you can take that 9-volt battery and increase the voltage on it sufficient enough in order to get a set of lights to light back up again. LED technology has really exploded in the last 6, 7, 8 years with the introduction of all these new LED lights that they were developing. So it was still kind of like a mystery out there how LEDs work, and the first ones were very sensitive and prone to failure. They didn't have a lot of brilliance to it, so a lot of people just didn't consider them a viable product, not until more product came out and more ideas and the versatility was there. They are still sensitive. They are still easy to destroy one of them if you're not careful, but with just normal precautions and all that, you'd be fine. The first LEDs came out with steel wires on them, and the steel wires is you get them wet, they rust, and then you lose contact. And then most of the first LED light strings they came out with, that's what happened. And so they started sealing them at that point. Well, sealed LEDs are harder to test because you can't pull a bulb out and put another one in there because it's all built as a solid unit. There's no way to do that. And so they finally changed the composition of the LED leads to aluminum with a coating on them, and now they don't rust. So the later LEDs work a lot better, but they will still fail. You know, you still have that mean time between failure that's still going to work in there, or power surges, or damage. I mean, just like incandescent bulbs and all that, if you take them down, throw them into a box, they sit there a whole year in storage, you bring them back out again, and you start tearing them apart. Incandescent lights and Christmas lights both could be damaged that way. And again, you need a tester to find out where it is I damaged the string and how to fix it. Well, it is a hobby to me now, and you know, but back then it was determination to fix those lights. And
yeah, because he had a huge box, and the hotel that gave the resort facility that handed these to him were just glad that he was willing to take them off their hands.
It was a pallet full.
It was huge. I mean, I could have gotten in it 3 times. It was so big.
An LED could last 40, 50,000 hours if it wants, you know, but that doesn't mean everyone is going to do that. I don't want to get too technical on the whole thing, so I'm going to try to dumb it down a little bit here. It's called mean time between failure, and what they do is they estimate how long a product will last. And they will take one product or one device that they're testing and see, it would take too long to test it and to see when it would fail. So they would take a bunch of them and test them all at one time and wait for a failure. And at that point they could equate what the mean time between failure would be over X amount of quantity that they're testing. It could be one of two things. It could be the ultra-fine micro wires that they use to make the electrical connection in the LED, or it's heat. And that LED is so small in there, the actual LED itself that's emitting all this light is so small, it will not take much to burn it up. And so voltage is very critical, and current. Current produces the heat at that point. So you've got to regulate the current on an LED to the manufacturer specifications. Normal Christmas lights and most LEDs work the best around 20 milliamps. There's a lot that go high, a lot higher than that, but for our purpose, 20, 30 milliamps is the maximum that you want of current you want to run through an LED. Well, John said at that point, you know, don't tell anybody what's in it. I don't even want to know. And I really respected him for that. And we went, you know, we did several discussions and all that before we sat down. And he says, okay, we're going to have a meeting and you can go ahead and divulge it now. So we were satisfied at that point that this was going to happen. So.
Well, but back up, hon. We were here,
Yeah.
and when we first got here, and they were all sitting around the conference room, and you handed the tester to, was it Jerry? I don't remember who took the tester, but they were.
Well, we were all around the table. I did my demonstration. I showed it to them. I pulled my tester out. I pulled my LED lights out, got it, and I proceeded to demonstrate it and show what it is. Of course, it was a known failure in it. I knew where it was and all that, but it was just the presentation of the whole thing. The capper of the whole thing was I had several other testers in my box of goodies, and I put them out on the table, and they went in their warehouse here and started pulling LED light strings out for me to test them. And I said, no, you fix them. So I gave them the testers and I gave them the light strings, and each one of them, with just a little bit of instruction, found the problem in all those light strings that they brought out.
And so then somebody says, I want to know what's in there. And Dennis says, well, we're not going to tell you what's in there.
No, John said that.
Yeah. But when we got back to the hotel, I said to him, I said, okay, I want to know what's in there because I had no clue what was in there.
At that point, I divulged it to her. So.
Not that I necessarily understood totally what it was, but I found out what was in there. I know John was a little concerned about, in the very, very beginning, about the insulation piercing. And I told, because Dennis repaired all of these light strings, and when we were putting them up, I was like, man, I can't find these little holes. Because in the sun, it's vinyl covering, plastic, rubberized, whatever. The sun heats it up enough that those things seal so tightly you cannot find them.
It's self-healing.
It's self-healing. And I've always thought it was amazing that he could, because there were some light strings that were really bad, and he probably put 4 or 5 dozen holes in those. But you can't, today, if we have some of those strings, and today you still can't find the holes because it seals up in the heat. But just a little bit of sunshine and it's gone.
I did all that due diligence I could to in order to make sure that this was a foolproof product. But I needed somebody to market it and had confidence in what I had and knew that this was the right tool to put on the market. I wanted the public to know about it too, and because I could see it needed to be out there for people to use. I didn't want people to think that LEDs were that terrible because one failed and they couldn't fix it.
Well, and I think the word is spread by individuals. For instance, the light group that Dennis visited recently, that they meet annually to help each other make their displays better. And they all know about the tool, and they spread the word as they communicate in the Christmas light decoration group that's across the world now. It's just about everywhere. But word of mouth is real important too, because we were in Crossville, Tennessee. There's the Cumberland Playhouse, and it's a community-run playhouse that puts on great little plays and everything. And we went to the Christmas show a couple of years ago, and we're in the lobby waiting to enter into the theater. And we're standing close to the concession stand, and a woman comes running in from the outside into the concession stand area, and she yells, "Oh my gosh, Jerry or my husband just fixed the Christmas lights." And the woman turns to her and says, "But weren't they LEDs? I didn't think you could fix those." And she says, "We found this great tool. It's called the LED Keeper." And I'm like, they're talking about your invention. And so I think those kind of people help spread it. But John is so dedicated, and we really appreciate all the work he does for us.
There's still a lot of mystery about it that I keep finding about. There's a tester for LEDs. Why do I need that? You know, and that seems to be the mindset that LEDs don't fail. And I don't know what it's going to take to convince people of that, you know, but John's sure trying. Even my display, I sat down and calculated, you know, 40,000 plus lights. How much power is it going to take to run that display if I turned all those LEDs on at one time? I sat down and calculated it, and I could run it off of one 110 volt outlet. Big savings on that. Electric, I don't know, I never really sat down and calculated the savings on power between an LED and incandescent, but people have written about that, and them putting in their own 100 amp panels just to run their display. And I'm sitting there just plugging it into my outlet on the porch and have a fully computerized display running, with one plug. But the other problem you run into is, well, LED light strings cost more than incandescents. That's true. Price is coming down on them. They're getting more affordable. The price gap is really closing on them. But they will not buy the more expensive LEDs because that fear of failure. And that's where the tester helps them at that point. If it fails, you don't have to throw it away. Now you can repair it.
I think it's amusing because the friend of ours that introduced him to John, has a personalized plate on his car, and his personalized plate says LED killer. So we have a personalized plate on our car that says LED fixer. And I just think that's amusing because it's real funny, because we were in Conroe, Texas at a big Christmas light convention thing that they have down there every year. And we came out of a restaurant, and John was with all of us, and there sat his car, and John looked down and he said, "That's just wrong." and our friend said, "But I burn a lot of them out." And John said, "But it's wrong, LED killer."
Our friend is into LEDs also, and actually he was doing testing for manufacturers' Christmas string lights. So he was doing all these destruct tests on the whole thing. And he saw my invention, and I gave him one, and he went, "Wow." He says, "I got to have one of these." So he actually got the first unit off the production line.
I really enjoy researching my family. So we've visited some places in South Carolina where my 5th great-grandparents fought the British, and that was a lot of fun to see those historical places and walk where they walked and know that our country is, it is what it is because of people, our ancestors who sacrificed their lives and fortunes. A lot of people don't realize that the American Revolution was funded by the citizens. There wasn't a government, and when a militia was raised, some local person provided the funds for the supplies and the ammunition, and there were uniforms, pretty much either they bought them themselves or whatever.
Yeah, the government back then didn't have any money.